So thank you. We are going to start with test of significance. So before we start, I want to do
cool demo.
No magic tricks. Just regular.
Magic tricks. Not social magic.
I love magic.
These are pretty good.
Oh yeah, I can see the little. It's a deck of cards. Ah! I see the little strip, but it wouldn't come off. You know the one you just slide on there? Screw that. I don't have time to be. I didn't want to go through. No!
You need a sticker.
What happened?
You need a sticker.
I know, huh? Okay, so thank you. Yeah, can you guys like chill? Well, you guys are so loud. I'm trying to get started with this lecture. Here you go. One for you.
Oh, that's great.
One for you. Joker's out. Okay. So here's what I want to do first. Thank you. So I got a deck of cards here, standard deck, and what I want to do is I want to see if we can draw a. Let's see here. If what the probability is that if we draw a card, the next card comes the same color. That makes sense?
Same color?
So
You
same
run
color.
into chance.
So it should be pretty basic. So I'll let you go and start and pick one. Now, go just grab one. Okay, what color is it? Okay, good. Put it back in. All right, cool. So next person, the pressure's on, because now you have to draw. What color was it? A red card. So you want to go? Okay, just grab one. What color is it? Red card. Nice job. So she did it. That was simple, huh? Oh, she replaced it. We replaced it back in. So we're just going to keep doing that. Let's see how many reds we can draw. That's pretty good. So you set up a good precedent. So let's see here. I'll be right up there. Hold on, let's see. Oh, I see you wanted to grab one. So I got a red card. Woo! All right, that's not bad. 3 in a row. Okay, let's do this again. So you go to grab. Red card. Whoa, wait a minute. How many is that? 4. Okay, you guys are pretty good at this. All right, so let's see here. No, that's not bad though. We could do that. You want to do it one more time? Got any card? Make it a black card this time.
I want to do it.
It's a red card.
Hey, you dropped the card.
No, I think that was a. Go pick it up. It was a zero card. Okay, go ahead and grab one.
Cheater pumpkin eater.
Black card. Red card.
No, they're all red.
What? What are you talking about? I just opened up the deck for you. How is that? You've seen my cards? What are you
They're
talking about?
red.
You're crazy. Black card, black card, black card.
I don't
Red
know.
card.
Who trusted this black cat?
What are you doing to me?
I want me to show you that cat.
I just opened up the brand new freaking deck. What the heck are you guys
You're
talking
lying.
about?
They're all red.
How am I lying?
Because I looked underneath the deck and they were all red.
You look. Why would you look underneath the deck? Red card.
That's 8 in a row. They're all
8 in a
red.
row.
How
What?
can they all be red? You just opened the deck of cards.
Exactly. Thank
Let me see
you.
the cards.
Shenanigans.
My
And it was a brand new deck. Look.
Look, it says jumbo. It says fake.
Those actually came from.
Casino quality plus special.
Go girl. These came from Gila River. These are the ones they use for their
They're
blackjack.
rigged.
How
No.
are they rigged?
That's why they have
Brand
little
new
old
deck of
punches.
cards.
Because they got one.
Okay, you guys are pretty sad.
How many
Anybody
is
want
in
to
a
try
row?
this again? See if you can. Thank you.
Let me see.
You guys are horrible. Excuse me.
I call shenanigans.
What?
How many's in a row now?
She calls shenanigans.
Hey, I want to go out here first.
One more time. Red card! One more time. That's freaking amazing. You guys are pretty sad.
Let me see the deck.
What do you want to see?
The whole deck.
You want to see the whole deck? The fact that they're all red?
Carl.
What the heck? Hey, I was robbed. That's not the deck I was supposed to use.
Are they all ready?
Yeah.
Thank you. See, you're defending him. Oh my god.
What the heck, dude? Why? You gotta be first. Why would you call shenanigans?
Because that's too
It's
many in a row.
impossible.
How come you didn't call me on the second one?
Because that's
it's
still
possible.
like decently believable.
But
Decently
after
believable?
like 8 in a row,
Okay, hold
I
on.
saw it after I saw all the red on the bottom.
Okay, so you cheated. That's cheating. So after 8 in a row,
I think after 5 in a row.
I'm listening
yeah.
to the wheels.
thank you. So I heard you call shenanigans, and then you said, why did you say I was not being truthful?
Because it's too many in a row.
It was too many in a row, but each event is independent.
But
How do
still,
you justify that?
like after like 3 in a row, it's kind of like
Significant.
iffy, and then like
3 in a row is
but-
what, an 8?
but
Let's see,
like
half point. It's it's like a 12.5.
but 5 after 5 it's like no, you can't do that.
After 5, you can't do that. Do you agree with that?
Like it's possible, but it's like very very rare.
Very, very, but it can still happen.
Yeah, it's like missed the beating.
So,
It just doesn't
oh,
happen.
but you still call.
Sorry.
So after 5, so that's why you called me on the 6th, 7th, and 8th. Did anybody else get suspicious? What was your point of suspicion?
Number one. The fact that you.
The first one?
Because I knew you were going to try to prove a point. I was just saying, the minute you pulled out a deck, I was
Okay, so you asked me for Wild Horse
It's
Pass.
you.
I can't even open a brand new deck in for you guys without calling it crap. Okay,
So
so
Gila
anyways.
River is rigged.
Yeah, so is it ever rigged?
Yeah, I spent the weekend fixing that deck.
Mm.
So it happened because
How'd you get it wrapped up again? You're tight.
He's
that what you-
you can buy him.
Oh, I thought you meant that like you actually like did all that. I was like, you went-
no, I did. Well, I didn't wrap it like brand new wrap it. It's called tape.
Oh,
It's
no,
called-
I
it's called
didn't know.
blue tape.
You're tight.
So, anyways, thank
I
you.
don't even know this.
Let me continue here. So, because the outcome of choosing that same card over and over was unlikely after a certain point, how unlikely was it? How unlikely? I mean, very unlikely doesn't fly in math, does it? I can say, well, you know what? That shouldn't happen.
90% of
You used some really good words because you said after the 5th time, then it becomes significant, statistically significant. I thought that's what you said, or maybe that's what I wanted to hear.
I said that.
Somebody said it. I know I heard it somewhere.
That's me.
Well, it was 0.5 to the K, right? Because if there's half and half, then the probability of drawing a red card is simply 0.5. So you take 0.5 and you keep taking it to its power. You know, getting a red card, getting a red card, getting a red card. That's a half times a half times a half times a half times a half until the probability of that actually happening is so small. Then you say,
nah.
right? Because like the first one, oh, that's a 50-50 chance, right? Even the second one, like, oh, 1 in 25, that's cool. It'll happen. After that is what, 1 over 12.5, and then it becomes 1 over 6.25. Even that's still kind of legit. But when that number is so tiny, then you're like, I don't know about this, right? So that's where it came in. And yeah, thanks for using the same word that I use, called shenanigans. So, what had to happen was that you had to first create a supposition. Okay? And I don't think if any of you guys even knew that you were doing that, but you did. Okay? And it's just a fancy way of it was unsupported. And does anyone know where that supposition came in? Where your supposition came in?
What is this? Oh.
After like the third one.
After like the third what?
The third draw of the card.
Okay, well, in order for you to say yes, you had to assume some things. Okay, and I don't think you guys really thought about what you did. But first, the first assumption was, all right, you know what? Let's assume that that is a regular deck of cards. Right? Okay, I'm going to suppose that that really is a legit deck of cards. But the fact that you're pulling so many reds so often tells me there's something shady going on. Correct? So, that's part of what you guys were doing there. So, was it a fair deck? The supposition shows up in this part right here, the math. you know what, if this really was a fair deck, then I should be able to capture the probability the way it should be if it was really a fair deck. Does that make sense? Okay? And which is the math part of it. And this is what you're using to say, okay, you know what, you drew the first one, you drew the second one, third, fourth, fifth, and so forth, and you were good. But at some point, you just said, you know what, this probability is so small that that cannot be a fair deck. Okay? So for starters, everyone created a hypothesis, saying, all right, I believe you, half and half. But then at some point, you said, I don't think so. I think there's more red than there is black cards in there. Yeah? Cool.
Cool.
So that's where test of significance comes in. And what we can do is we can actually take a test and say, you know what? All right, let's take a look at what you're saying, and let's see how true that is, because I'm actually going to provide for you an alternative here. Let's not go here. I want to end this one, and I'm going to jump over to here, because this one has some vocab in there for you.
Is that our homework?
Yeah. You guys want to write that down now?
Is it 1 through 8 equal?
It's all of them.
All?
Yeah.
Do you know what page?
Okay. So. What?
How long ago?
We're good? All right, cool. Let's get started. So, first thing that you're going to have to do is to state a hypothesis. And what a hypothesis, just simply saying, is that you're going to make an assumption or a claim. For example, how polluted water is. I believe there is so much, lead in the water that it could be deadly for you. Okay?
Can we test this?
And what we're going to do is we're going to clean it up. Okay? So for starters, we're going to say, hey, you know what? Water, it has this much pollutants in it, blah. Okay? We're going to do something to it. We're going to treat it, and we're going to see what the effect is after that. And we're going to believe that the amount of pollution is actually going to be less than that. Okay? So first you need a hypothesis. Now there's going to be two types of hypotheses you're going to start with. And every one of these probably should have two of them. One is going to be the null hypothesis. Yeah, I can write on this. It's the null hypothesis. And the symbol we use to represent the null hypothesis is H naught, or H sub 0. We just call it H naught. And H naught is simply the null hypothesis. It's the one that we really don't believe. Okay? It's the one that we really don't believe. Now, the null hypothesis should always be stated in the form of a parameter. So it's either going to be a p or it's going to be a mu. Okay? So you can say that the mean pollutants is equal to, 5. Then you're going to do a test of some sort, or you're going to change your product or whatever, and then you're going to provide what's called an alternative. And that is simply H sub A. So you have your H naught and your H sub A. And your H sub A can come in a couple different forms. One, you can say the mean pollutant is going to be less than 5 now, which means something good happened, right? I was able to clean up whatever I was doing. For some reason, sometimes you might want to say, hey, it's greater than 5, or the quality is increased. Okay, quality level could be 5 to start with. Now I believe that quality level is greater than 5. Or you can say equal on both sides. These two tests are called one-sided tests because you're simply looking at the probability being greater or the probability less than. Because we're saying not equal to, that means you could be either one of these. You can be below or you can be above. So this one would be called a two-sided test. Visually, if you're looking at the distribution, that would be a greater than. This would be a less than. And this would be, oh sorry, not equal to. And this would be a not equal to. So this is why it's called a two-tail. You've got area on both sides. Equal to? No. No, because what you're going to start off with some fact that you already know about the population. For example, the quality level could be 5 of water.
What's your hypothesis
No
no matter what you do, the quality is going to be better?
matter what you do.
Yeah, like what is
Well, you wouldn't run a test if you didn't believe something was not true. For example, in the card trick that I did, your assumption is that all the cards are the same. You would say the probability of the cards is not the same. You would provide an alternative to that. But yeah, it would always be equal to here. These are your 3 options for your alternate. Okay? Now let's say this probability for a one-tail turned out to be like a 0.26. If it was the other side, then this would still be 0.26. Does that make sense? If you're actually looking for a less than or above than, because that area is the same. However, if you're going to a two-tailed, this would be 0.26, and this would be 0.26. So notice that when it's a two-tailed, that probability actually doubles when it's a two-tailed, because you've got two tails to worry about. Okay, area would be 0.26. You'd have to make sure you double it for the other end. Okay? Questions on that? Okay, so what we are testing when we do our statistical test, that's going to be the null hypothesis. And that's what we're going to be gathering evidence against. We want to reject the null hypothesis, because the null hypothesis is the null one, the bad one, the 0 one. Okay? We don't want that one. We want to prove that what we're saying is true, the alternative that we're providing. So whenever we're doing these tests of significance, we want to make sure that everyone keeps in mind we're trying to disprove the null hypothesis. And we're trying to find evidence to support the alternative. Sad face. More glacier freeze. Are we good? Oh, I already said that. Here you go. Now, of course, everyone's going to ask this question. You know, which one do you use? Do you use the greater than, the less than, or the not equal to? And that's really going to depend on what the problem says. Do you guys remember those where it said, where some of them, they gave you a bunch of formulas to set up for standard deviation, and you had to figure out whether it was equal, greater than, less than, and all that good stuff?
Yes.
Well, the context was in the problem. It said, you know, you're looking for the probability that more than this or less than that. Same idea here. So you're going to have to read the problem very carefully and decide what that's going to be. And I think I already talked about one side, two sided as well. Yeah, make sure that you do, never write any of your hypotheses in terms of p hat or x bar. Once you do that, you're wrong. Because what are we always searching for? The true mean or the true proportion. Never the true statistic. We use statistics to make that decision, okay? All right, cool. Interpreting p-values. What? A p-value? A p-value. Okay. The probability computed assuming h naught is true that a statistic would take on a value as extreme or more extreme than the actually observed is called the p-value. So p-value, p can probably help you with probability, but we don't ever call it the probability, we call it the p-value. And then of course the smaller the p-value, then the stronger the evidence is going to be against the null hypothesis. I should go ahead and give this to you right now. I love this. Remember that. Remember it. Write it down. Take a picture. Commit it to memory. If the p-value is low, the h naught must go. If the p-value is low, the h naught must go. And that is h naught, gentlemen.
Question. How do you know if the p-value is
You gotta go. I don't do
Mr.
We'll talk about it.
If the p-value is low, the whole must go?
H naught. I know, that's every year I get that. But and it is funny. Last year class even thought about putting that on a t-shirt.
We should.
But then emphasize, like,
Put another color.
yeah.
Yes, the smaller the p-value, gentlemen, we're not trying to make the p-value larger. The p-value needs to be small in order for it to be statistically significant. And the p-value, again, is simply a number representing the probability. If the probability of some event happening is very small, then and it happens, then you say, just like these ladies up front called in my game, in my example, shenanigans. The probability that happens is so small, there's no way that that can be a legit deck of cards.
So if the probability is low, the hypothesis is incorrect?
You got it, yeah, pretty much. So if you turn out and get a p-value that is very small, then you reject H naught. And I really like it. It's just kind of catchy and it helps you remember once you get to the end and you do have your p-value. So if the p-value is low, H naught must go. So small p-values are evidence against H naught because the probability of them actually happening is very unlikely. Large p-values fail to give convincing evidence against H naught.
What?
So, and I know that's really weird. This is probably going to get weirder to you right now. Once you do find your p-value, there are only two options that you can do. One is you can reject H naught. If the p-value is low, you can reject H naught. If the p-value is not low, then you will, what's the other option? I know, everybody wants to say accept, and you cannot accept H naught. You are going to fail to reject H naught.
So it's like,
Those are your two options. Go ahead.
like when someone like, were you at the baseball game? It's like, I'm not saying I wasn't at the baseball game.
Very similar. Actually, it's more like when you're when someone's at court and they're being charged with something. There's only two verdicts, right? You're guilty or not guilty. Do they ever find you innocent? No, because there wasn't enough evidence, or you cannot find evidence to prove innocence. All we can say is you're guilty, or we find you not guilty. So the same idea with our mathematics. Remember, we were trying to reject H naught, weren't we? If we don't reject H naught, are you happy with that? Or you're going to be like, all right, cool. No, you'd be like, oh, you know what? It's kind of like taking the other side. Well, I just didn't have enough evidence to suggest that you were wrong. So these are the only two ways that you can interpret your p-value. You're either going to reject H naught, or you're going to fail to reject H naught. You will never accept it. If you accept it, you fools.
Never accept.
You're wrong. You just lost points.
Ever.
Questions on this so far? Making sense? Good stuff. Right on. And when do you reject H naught?
When the
When the p-value is small.
If the p-value is low, the home must.
The H naught must go. H naught.
It's easier to say.
That's another fantastic question. We'll get that to in a minute, okay? So, here's the two things that we can say. Man, I'm just like in front. I just need to trust my slides, huh? So you reject H naught or you fail to reject H naught, okay? So the question was, how small does the p-value have to be? So we need, in order to do that, we first need to decide on a level of significance, which we're going to call an alpha level. It is an alpha level, and that character you've seen there is an alpha. So let me connect alpha with what we did last chapter. You guys remember if we did a 95, level 95% confidence interval? What are the chances of us making a mistake?
5%.
That's your alpha level as well.
That's your alpha level.
Is the 5% the margin of error?
No, it's not the margin of error. The margin of error is something you have to calculate with your critical
So
value and standard deviation.
The 5% is the what? Alpha level?
Yeah, so 5% would be the alpha level.
What's that?
And that's pretty much how, so here's what you're saying. So you're saying so if I convert that, it's what, a 5% probability, right? 0.05?
Yeah.
So for you, when I was doing my example with the cards, you said after 3 cards I was suspicious. Someone said after 5 cards, someone said after 6 cards I was suspicious. Okay? Everyone understand that that's kind of like your fine line, right? And once I crossed that line, then it was like, I don't think so. That's what your alpha level is. It's that red line that says, you know what? Once you've crossed this threshold, now I'm suspicious. There's a few shenanigans going on. So, if we were doing, I don't know, I was fishing and I caught all kinds of fish, blah, 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 whatever. And you're like, you know what? I don't think you ever catch that many fish. So you did a test of significance to see if, that was really it. And you turn out that their probability for catching that fish was a 0.07. Is 0.07 small enough for me to say, dude, you're lying? Not really. Not if you're looking at a 5% probability. Okay? So it has to be smaller than 5% to say, oh, that is significant. It shouldn't happen to you. Okay, do you see how 0.07 is larger than 0.05? So that's still within our threshold. So you'd be like, all right, it could have happened. Maybe it was a good day, the stars were aligned, and all that good stuff, and but beyond your capabilities, you were still good. Within your capabilities, yeah?
With the confidence, like, with the card trick, so, like, the probability, like, any probability after 0.05 would be no.
Yeah, so now if I said, you know what, the probability, Angelo, if you fall asleep in class is a 0.03, then that is pretty significant, isn't it? Which means it's probably going to happen, or sorry, that shouldn't happen because it's so small, but it did happen, so I'm like, oh, something's going on. Angelo, did you get sleep last night? You must have been playing with the band, till midnight or something, huh? Okay? But if the probability is really small, okay? Now, everyone understands the probabilities are smaller, right? But all you need to think about your alpha level is like that fine line. Once I cross it, it's significant to me. If I'm on the other side, then we're okay. Okay, so here's an example. Ready? hopefully this clears it up a little bit for you. Better batteries. A company is developing a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to convince that they really do last longer. So based on years of experience, the company knows that its regular AAA batteries last for about 30 hours on average continuously. The company selects an SRS of 15 new batteries and uses them continuously until they completely are drained. A significant test is then performed. Now, notice this. If there's nothing special going on, how long should those batteries last? That's why it's the null hypothesis. Do we really believe this? Does the company believe that?
No.
No, what do they believe?
Last longer.
That it's greater than 30. So there's the purpose of your null hypothesis and your alternative hypothesis. We're trying to disprove this. We're trying to disprove it. So we create our test, blah, 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 and they found that the p-value of that result was a 0.02. Is that significant?
Yes.
Well, I don't know. Is it significant at the alpha of 0.05?
Yes, it is.
Yes, it is. So did that happen by chance?
No.
Probably not. Now, is it significant at the 0.01 level? It's really not. So, because the p-value is not low in this case, then you have no evidence to suggest that the batteries last longer than 30 hours, and you say, you know what? So we fail to reject the null hypothesis, and we say, you know what? My bad. Our batteries don't really last longer.
For more money.
They just cost more money, yeah, because we put a new sticker on it that says deluxe. Questions on that? Processing? Process? Daydreaming.
Talk about their cardboard chariots.
Oh, that is always fun to watch. You guys are doing it again?
No.
No! Yeah. So, one more time. So, thank you. So, since the p-value of 0.02 is less than our alpha level, then we say that this test was significant. Okay? So, because the p-value is low, we reject the H naught must go. So, you're going to go with the alternative. So then in your interpretation, you'd say, because the p-value is so low, we reject the H naught. There is significant evidence to suggest that the new deluxe batteries last more than 30 hours. I'll repeat that. Because the p-value is so low, we reject H naught. There is significant evidence to suggest that the new deluxe batteries, on average, last more than 30 hours.
So they do.
They do.
I feel confused.
Because now for part A, when we're using alpha level A here, this is the alpha level. That's the significance. If it's beyond that, then it's important, isn't it?
Yeah.
Okay? So, p-value is low. H naught must go. Okay,
So
so
it rejects the null hypothesis.
right. The evidence we're suggesting is to disprove this. We don't want to believe that. We want to believe what we're proposing.
And then that's the alternative hypothesis was
Is what we think.
not guilty. Kind of.
Correct. I think.
I think.
Now, when our alpha level is 0.01, well, is that number significant? No. So, because the p-value is greater than 0.01, there is insufficient evidence to suggest that our batteries last longer than 30 hours on average. Or you would say, because the p-value is greater than 0.01, we fail to reject H naught. There is insufficient evidence to suggest that the new deluxe batteries do not last more than 30 hours. Oh, very well worded. We do not have enough evidence to reject H naught in this case, therefore, we cannot conclude that the new deluxe AAA batteries last longer than 30 hours on average. Yeah? Exactly the same. Exactly the same but different, right, Jose?
Same difference.
Questions?
How do you find a p-value?
A p-value is going to be given to you. A p-value is going to be given to you. If they don't give you a p-value, then we use our rule of thumb. And you guys remember what the rule of thumb was? You guys remember the rule of thumb for the confidence interval?
95%.
95. So if it's a 95, then our alpha for a thumb would be 0.05. So if they don't give us an alpha level, we go with 0.05. Okay? Fantastic. Oh, this is good. You guys doing okay? Type 1 and type 2 errors. Type 1 and type 2 errors. Let me try to explain this a little differently. Did I spell that right?
The girl cries. Girls cry wolf.
The girl cries wolf. So this girl cries wolf. There's a wolf. There's a wolf. What is the H naught? Well, H naught.
Not a boy.
Okay, we'll believe you. We will believe you. There is a wolf. Okay, we'll believe you. Okay, wolf, we'll believe you. So, here's what can happen. We can believe her that there is a wolf, correct? So, we believe her, and there is a wolf. Hold on. Now let's do this. There is a sorry, I'm trying to do it a little bit different so it makes sense. So if there is a wolf and we reject her, so if there is a wolf and we say, whatever, this girl cries wolf all the time. That is the type 1 error. That is the type 1 error. So the type 1 error is when H naught is true and we reject it. So like you're telling us the truth and we reject it. That's called the type 1 error. Now, if there is none and rejected, then we're good, huh? I mean, that's okay. There's no problem there. What if there is a wolf and we fail to reject it?
Hey, I'm confused.
We're good, right? So in other words, there was a wolf there, and we didn't say she was lying, we just failed to reject it. We just like, okay, oh wow, it turned out there was a wolf. Good for us.
We didn't die.
We didn't die. Now, what if there is no wolf and we fail to reject it? That's your type 2 error. Now, think about this. Sometimes, actually, let me ask this question. Which one's worse, the type 1 or type 2?
Because if we fail to reject it and we believe that there's a wolf and there really isn't, then we still prepare.
Say that one more time, nice and loud.
Because if we fail to reject it, then we believe that there's a wolf and there's really not one, so we're prepared for it anyway.
Did you ever hear that? So, there is no wolf, but we prepared and there was no wolf. What's the penalty for that?
Nothing.
Sorry. Nothing. I mean, we just lost some time, right? But what if there was a wolf and we didn't believe?
Then we're screwed.
Then what happens?
Die.
Some people could die, couldn't we? Wolf attack, well, not rabies, some people. So, in this scenario, which is the worst mistake you can make? Type 1 or the type 1, right? You're going to have to take a look at every problem individually. Because sometimes making the type 2 error would actually have greater consequence than the type 1 error. Depending on how you wrote your hypothesis and what your conclusions were. Yeah? So here you go. Okay. I don't even know what you're saying. I don't think anybody does. Wolfgang? Wolf? Wolfgang. Are you making fun of my accent? Yeah. What accent?
Haters gonna hate and getters are gonna gate.
Can we continue? Okay. Perfect potatoes. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. Victoria, will you read this for us, please?
Now we're even talking too.
Oh, will you read this for us, please?
The whole thing? A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, the supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses. Let's read that part too.
Yeah, what's the H not?
K equals 0.08.
And what do they believe?
What?
What do they believe? They believe that the proportion of potatoes is actually more than that. Because that's the alternative they're proposing. Okay. Okay, so can we describe the type 1 and type 2 errors and what the consequences could be? So let's start with
Blemish.
So let's say that the potatoes were, in fact, 0.08, and we reject the potatoes. What's a possible consequence here?
That there's actually less than 8% potatoes in the truckload. 8% of the blemished potatoes in the truckload.
Well, I mean, that would be pretty much a given if it is that. Okay, because we're saying it's more than that. But what's one of the consequences, like real life, reality? That's what you really want to think about.
The chips are not a good quality.
What do? You waste potatoes, or you don't have potatoes to make your chips. So if I don't have potatoes for my chips, then what could that eventually cost me is money. Okay, so that's not so bad. Maybe I send them back and I get another supplier. So maybe I don't waste money. Maybe I just waste time. I know they're the same in the business world, but perhaps here I just had to wait a little bit more for good potatoes because I really didn't buy them, did I? So you know what? They're not 0.08. If they are greater than 0.08 and I reject them, then I'm good, right? If they are equal to 0.08 and I fail to reject, I'm good because I got me some potatoes. But what if there were greater than 0.08 and I failed to reject?
Lower quality of your potato chips.
Lower quality potato chips. And if I've got lower quality potato chips,
Unhappy customer.
Then I've got unhappy customers, which is probably, definitely potentially going to cost me money. So in this case,
You
the
lose
type
money.
2 was a little bit more damaging than type 1, wasn't it?
Yeah.
So again, take a look at every scenario and consider them how each one affects the other. Okay? Was that a question or distraction? Cool beans. Okay. Power. Do I want to get into that? I don't. Yeah, because this is a lot. Okay, I'm going to end it here.
Thank you.
So just remember where I left off, which was slide 10. There's only like 6 more slides. All right, cool. Get started on the homework then.